Hello everyone. This is the video lecture for College Algebra Math 1314 Section 2.1. We're going to start talking about functions. And so we're going to learn as we go, of course, so let's start with this. We have a set of points. I got 1, 2, 3, 4, 5, 6. Is this a function? The answer is yes. But why? Well, the definition of function is going to be that each x value has only one y value. So each x has only one y value that's attached to it. And so this 1 has only a single number, this 3 has only a single number, and this 5 has only a single number. If you had something like, say, 5, 6, and 7, obviously that would have then 2 numbers, and that's not a function. But it doesn't actually look like this whenever you're looking at the homework. Instead, it would have 5, 6, 5, 7 separated. I know that it looks like each of these has only a single y value, but you're repeating that x value, and so technically there is actually 2 y values for the one x value, which again, not a function. So that's what it looks like in reality. I guess in a way we can break this down to a simple way to see this. So watch out for repeated x values. Repeated x values. Not saying that it's automatically going to be wrong, but at least it's suspect. I say the only time it could be right is if you have, say, 5, 6 and 5, 6. Well, they're literally on top of one another, and so you just don't write this because they're a copy, and then is this a function? Yes, and we're good. So domain and range. Domain are going to be the x values. Range is the y values, and so that's the first and the second numbers, 1, 3, and 5. Here we got 2, 4, and 6. Let's say that we had another point. I'm just going to make something up here. What if I had 7, 6? Still okay. Two different y, or two of the same y values is fine. It doesn't change anything. It's just repeated x values we're looking for. So this is okay. This is still a function. But would I put 6 again? I don't think so. Don't do that in the program for your homework. Just, put a single instance of each of those y values. Okay? Cool. Next problem. So they're asking if this is a function. Notice now algebra of, letters and stuff, an expression, instead of just a set of points. The definition for function is going to be, yet again, only one y value for each x value. I didn't put a y in there. There you go. Y value. And so when we have these letters and stuff, what that looks like is y equals blah, blah, blah. I don't know what's going to be after that, but if you get a single y equals, then you're good to go. So can I get a single y equals out of this? Well, I'm going to minus x squared on both sides. And so I got y is equal to 23 minus x squared. So yes, function. We're good to go. But now let's try a couple others since we're here. Let's say I had x squared plus y squared is equal to 23. Same procedure. We're wanting to get that y squared on one side. And so to get rid of the square, you square root both sides. The thing is, though, when you square root both sides, you got to remember there's a rule. You must have a plus and a minus. So in reality, what we're looking at here is two separate functions. We got a positive version, and we have a negative version. Trying to make that look right. That's a 23. Do you have a single y equals? No. So not a function. Not a function. Just making it quicker. Okay. So let's do one more. Let's say I had x squared plus y cubed is equal to 23. Again, same procedure to see if this is going to work here. So y cubed is equal to 23 minus x squared. To get rid of the cube, you need a cube root both sides. And so you get y equals the cube root of 23 minus x squared. Well, there's a rule for this, isn't there? Yes, it's only positive. So many rules. Do you have a single y equals? Yes. Function. So yes, that's good. So is there a quick version to see these if functions or not? So notice this is a 1 power. There's a 2 power. That's a 3 power. So function, not a function, function. It looks like the odd powers make functions. Even powers are not functions. Again, that's an odd, so it'll be a function. What if I had a 4? Not a function. Okay. Cool. Keep going. This one's a moderately tricky problem here, and so let's work on it. First off, we're going to plug in these values. We're substituting values for x. Notice that was f of x, now it's f of negative 6. So wherever you see an x, I'm now going to put a negative 6. So here it goes. Negative 6 squared minus 4 times the negative 6 minus the 5. So I got 36. 2 negatives make a positive 24 minus the 5. And I should be able to do that by hand, but again, I'm being very cautious and using a calculator to make sure that I get it right the first time. So 55, we're good. That's it. We're done. The next one's actually the most difficult, and I want to save that for just a second. Let's work on part C right quick. So again, everywhere you see an x, now I'm going to put a negative x. Negative x. And so 2 negatives are going to make a positive x squared. 2 negatives are going to make a positive 4x, and then minus 5. You're done. There's nothing else to do. So that one's, again, pretty easy. This one here I'm going to bring off to the side. It's a little bit more difficult. So wherever there was an x, I'm going to leave a blank. And you can do this for your notes. I think it's kind of handy for notes so you can kind of see your steps. And now what goes inside the blank? It's x plus 8. X plus 8. Now, technically, that is your answer, but we need to simplify it for the the homework program. So let's start working on this. I got x plus 8, x plus 8, and here I'm going to distribute the 4, so 4x minus 32, and then minus the 5. This one here you have to FOIL, and so x times x is x squared. X times the 8 is 8x. 8 times x is another 8x, and then 8 times 8 is a 64. Just copying down all the other stuff. Combine like terms, you're stuck with the x squared. That's easy. Your regular x's are here, and so that would be 16 minus 4 is going to be a 12x, and then you got your 64 minus 32, and then minus another 5. I believe it's 27, but I just want to make sure, okay? So hold on. Yep, we're good. It's always okay to double check yourself with a calculator. I just want to make sure I'm going to get this right the first time. And there we go. That was it. So not too bad. Still a little bit of work, though. Okay, let's keep going. Number 4. And I'm not doing every part of number 4. Just part D was very important to me. We're going to be substituting, plugging in. So wherever you see an X, I'm going to now, let me use a different color here. So wherever you see an X, I'm going to now plug in this 3a. So it's not technically very hard, but the answer is just kind of weird looking. So 3a to the 4th, 7 times 3a squared, and then minus 4. You actually do distribute your fourth and square to these guys because everything's being multiplied. If you had a plus sign on the inside, like 3 plus a or something, you could not do that. And I just say those words however you need to simplify this that you normally think about it. So 3 to the 4th, again, definitely possible, but I'm going to use calculator just to make sure. 81a to the 4th. I got 7 times, and we got 3 squared is a 9, a squared. That 7 is still going to be multiplied there. We're going to do some more work with that. And then we got this 4. So 81a to the 4th, and then 7 times 9 is 63, a squared minus the 4, and there you go. It was actually very simple, but the thing is that it has that a instead of an x. You have to type the a in the homework program for it to actually work correctly, okay? So watch out for that kind of stuff. They're going to try to trick you. It's not hard, though. Let's keep going. Number 5, now they got graphs, and they're asking, is the graph a function? What they're actually going to be using here is the vertical line test. So vertical line test. Guess I could have written that up earlier. Vertical line test. Well, let me demonstrate what I'm going to do here. I want to run vertical lines, and again, I only want a single y value, okay, for every one of these, single y value. So there's a vertical line. Did I touch it once on the graph? One single y value, yes. What about right here? Once, yes. Once. And I know it looks like this is vertical, but it's not. It does keep going, this way, I guess you can say. So once. Everything's once, one y value everywhere that I'm touching the graph with a vertical line. So is it a function? Yes. That's good. Basically, a single y equals I found for every single one of those points. Awesome. Well, let's do some other ones. What if I had something kind of like this? And so then once, forever, once even right there. Nothing on this side, so I don't really count that. Doesn't really matter. Everywhere I touch a graph, I'm only getting a single one y value. Yes. So I'm going to say function. Yes. All right, let's do another one. Let's say that I have well, that's not a circle. It's close enough for demonstration purposes. I run one vertical line. Nope, I'm touching twice. Two y values is no good. So here, I'm going to say not a function. Not a function. And notice that I didn't have to test anything else. If you got one part that doesn't work, the whole thing's not going to work. Okay. There's a couple other variations. I think that's good enough for now. Keep cruising. So number 6. They say find f of 4 given all this stuff. Well, normally we have f of x, and that's f of 4, so x equals 4. 1, 2, 3, 4 right there. And so I'm going to, I guess I would like to zoom in almost, but I don't want to do that. I'm going to start at the 4 and go down to the point, to the graph, and then I'm going to cut over, and you can see the y value. This is the y value that we're looking for, and you can see that's at -1. And there you go. Now, I want to use a different graph for another example. Let's just do something kind of like that. That's good enough. So 1, 2, 3, 4, 5. 1, 2, 3, 4. That's going to be close enough. Okay, I'm trying to make it lined up like this. And so the question now is going to be f of x is equal to 4. What is your x value? It's going backwards. And so notice that I start here at 4, and I'm going to go and then go down. You can see that it's going to touch at 5. X is 5. So this was my y value. Now they want the x value. It's going backwards. A little different, but I wanted to at least show you the two different styles that might come on your homework. And number 7. So this one and the next one are very similar, where they're wanting the domain and range from a graph, and there's a lot going on here, a lot of new stuff, but we got to get through it, so here we go. All right, so domain and range. Remember that this is x values and y values, okay? So the way to tackle this is I start over here, and there's no graph, nothing, up until it seems -2 is where I start. So -2 is where I start, and then my graph ends here at 0, and then there's nothing past that. So I want to say my domain, I want to say from -2, that's a terrible from -2 to 0. That's what I want to say. Of course, the homework program will not accept that, and so what we need to do instead is put it into math language, I guess you can say. What they're wanting is interval notation. So they're going to go -2 to 0 like that, and now we need to use either square braces or parentheses. And so we have to learn a little bit about what's going on here. The open circles like this use parentheses because that's basically saying that you're not touching that point. Rather, you have these solids down here, and solids are going to use square braces, or if you want to say bracket, that's fine too. So square brace bracket versus circle parentheses. So -2 had an open circle, so you use a parentheses. 0 had a solid, and so you're going to use a bracket. So solid versus circle. That's how I designate these two types of points there, okay? This is actually your answer that you're going to put in for your domain. Not too bad. The range is going to be similar, but notice that we're always going from negative to positive. And so what we're actually doing is, I'm going to use a different color. We're actually going to start down low, and then we're actually starting here, if you could see at -1. We go up, up, up until, I think that's 5, isn't it? 5? And then there's nothing past 5. From negative to positive. That's how we're going here as well. It's just that, here it was left to right. Here we're actually having to go bottom up. Okay, so again, I want to say from 0, I'm sorry, from -1, that's my y value. 0 was the x value. From -1 y value to 5 y value, they won't take that, so we have to rewrite it in interval notation. At this -1, we have a solid, so there's a solid for this guy, but at the 5, there's a circle, so you have to use a parentheses. And that would be your answer for your range. Okay. The remaining, questions are the x-intercepts and the y-intercept. So there's plural and singular. I have to use a different color. So where is it touching the x-axis? And you can see right here, it's going to be at -1, and they want just the number, not a point form, nothing else, just the number, okay? Y-intercept, where is it crossing this y-axis? Right here, yet again, actually, at -1 of all places, but that's fine. So where is it touching? Just give me the number, okay? All right, and last question. It's very similar, but this one has an arrow, which is going to indicate infinities and stuff, okay? So let's kind of work through this one. My domain, again, going from left to right, negative, positive, nothing, 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 up until 0. So I'm definitely going to 0, and then you can see this is going to go off until infinity. So you put an infinity symbol after it. So at the 0, you can see that we have a solid there, so you definitely want to have a square brace there. But the infinity is going to need a parentheses. You always use the parentheses with the infinities. So if you ever have an infinity, always needs to be a parentheses. That's just the rule. Okay, so that was actually pretty easy. The range is interesting because, again, we're starting down here, so negative to positive, so nothing, 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 until you can see it's 3, and then it keeps going up and up. This will keep going up forever, and so it will go 3 to infinity. Again, solid for the 3, so square brace, parentheses for any infinity that you see. I've seen some variations on the homework because everything randomizes, of course. What if it were to go like this? And I'm just going to talk about it. So notice that, yes, it's going down, but when you're doing your range here, it's a little different. So you're starting down here. Is there a graph that coincides here with, say, like -10, -100, something like that? And the answer is yes. It's just going to take it a while. It's going to always be going down, but eventually you will have a graph there. So technically, you're going to start at negative infinity and go up until, let's just call that 1 right there, up until the 1. And so your answer here would be negative infinity. This is your range. Negative infinity up until the 1, and then you're done. Now, I've seen a lot of times where folks flip it and do something like that or something incorrect. Again, always negative, most negative to positive, okay? Most negative to positive. And so even if it's kind of, it looks like it's going down this way, true, but we start way down here and move upwards, and that's why we have to put it in that order, okay? So just wanted to talk about it. I've seen different variations. X-intercepts, where's it ever crossing the x-axis? It's never doing it, so basically you click the none button. You just, I don't know, on the side you would say none. There's a none button. Click it. And then your y-intercept, it's right here. It's crossing the y-axis at 3, so you just put the number 3, and that's it. You're done. And that's actually all the questions we have for this section. So, thank you very much, and have a great day.